Hey, this is Brad Beltman for INFA725. This is exploit 1. I'm going to start by showing you my XP machine. I'm using ESXi, so I've got a target machine here, Windows XP. This one happens to be SP3 because it's just a snapshot of a machine I was using for the practical malware analysis. So I've got a lot of the other tools on here as well. So I just branched off from that snapshot and using it for this. You can see my IP address here. You can see that 143 is listening. Storage mail is running in the background. I've got AVG running. It's up to you. I'm not sure why it's got the exclamation point, but I'll check that out later. I've done the exploit several times with AVG, not complaining, and it's all up to date, and it doesn't catch anything, so it's kind of interesting. Oh, and I'm on dual monitors, so if you see any windows come flying in like that, I'm just grabbing it from the other side. Sorry you can't see that, but that's what that is. Here you can see my backtrack machine where I finally did get a shell. So I decided to run this before I did the video so I wouldn't make you sit through the boring part of me pushing, up enter after I tried the initial exploit, and I'm glad I did, because every other time I've run this takes 10, 15 or so tries roughly, and of course right before I do the video it took 63 tries this time. I was getting a little bit nervous as to why I didn't think it was going to work, even though I'd seen it work several times before. So glad I did that. Didn't make you sit through that, because yeah, it was painful. Here you can see the parameters I set. This is what I called the exploit when I wrote it, using the example from the book. Here's my remote IP address and other parameters. I just decided for the demo to use reverse TCP shell, and you can see I finally achieved that down here. Over at some other tabs here, let's look. Now this is the exploit code, the exploit module, following the example out of the book. And here's all of basically the metadata that Metasploit likes, including space we have for payloads and things like that, bad characters, and down here's the actual exploit function itself. You can see the padding of NOPs for our NOP sled, the offset that we ultimately came to after doing several rounds of fuzzing and things like that, and that's also minus some of the jumps we're doing here, and also minus the length of the payload, obviously, because we're going to need some space for that. Here is our near jump and our next SEH jump, and the reason that the book decided to use this particular technique of jumps is when our initial jump happens, it happens towards the end of the stack and it doesn't have enough to do the larger jump that we want to do. So basically we're jumping back a little ways into the string of characters that we're sending back into another jump that we've put in there, because that jumping back will give us enough space to make the larger jump back into our NOP sled, so it can hit that and eventually run our payload at that point. Here is our list command that we're sending into IMAP, plus the everything strung together up here, and the word pwned for style, I guess. Now, on the subject of bad characters, I followed the URL from the book, and their basic their idea was that we're going to send all of the hex characters, basically. We're just going to send that at the end of our payload of A's, and we can figure out which ones are getting mangled at the end of the strings there, or they're either mangled or not there, and that way we can eliminate bad characters. And so I stole some of your code from the exploit 2 video, and that's what you see down here is some of this. This is Python script, by the way. You can see some of this down here where I'm doing the connection, the login, all that stuff, very similar to what you were using for exploit 2. Up here is all the hex characters that I copied from the website, and I ended up, it wasn't working the way I expected it to. So I first tested this with just the A's to make sure it was crashing like we thought it would, and it was working fine. When I throw any hex characters at it afterwards, it doesn't like it. Or I guess I shouldn't say that. It does like it because it gives me an okay. It basically tells me that the list was okay and no crash happens. So when I was trying to figure all this out, I pulled out TCP dump and Wireshark, and here's one of the last ones I did. So you can see up here, connection happens, login's okay, do the list, there's the 10,360 A's or whatever it was, and I tried different lengths for that too with this. I tried 11,000, I tried 111,000, just to see the differences, and if I put the hex characters at the end, it gives me this list okay. If I take them out, if it's just the A's, this exact same length of A's, the program will crash. So I'm not 100% sure what I'm doing wrong there. I'd love some feedback on that. Like I said, I tried all of the characters at first. I tried cutting it down, as you can see in the code. This last try here was just numbers, as you can see, and it still doesn't like it. From the example from the book, the actual exploit, if I replace this with pwned, it seemed to work just fine. So I'm not sure what's going on with that. It might be something completely obvious or so I'm just missing, but it's frustrating because I wanted to get those bad characters out of there and see if I can make it, a really good exploit without having to run it 63 times before the video, but it just wasn't working for me. And throwing those in there seemed to make the application happy. So not sure what's going on there, but if you have any feedback, I would love to hear it. On the rest of the code. So let's see, where am I in the code? So there's from the top. Just got these set in as variables, all the hex. I'm just doing the basic connections here through socket, and then there's the end. It's just the receiving the data in the closing, basically. So if I run this the way it is now, well, actually, I guess the way it is now, it crashes it will crash the application. If I run it with any of the hex in there, application seems to like it just fine. So kind of strange, but anyway. Oh, the other thing I was going to mention was I should have maybe started with this. The fuzzers. I didn't. When we did the initial fuzzer, which is this one right here, I didn't just modify it as I went through the example in the book. I copied it and wrote new ones. So I got fuzzers for the different stages that we were doing. The original, the long buffer. So after we did the original, we were throwing just random junk at it to see what happened. I think it was the 11,000 offset, and then I've got the other two, where we're looking for put in the no repeat pattern so that we can figure out the exact offset and use the MSF PE scan to find that. And then I've got the actual offset where we're doing kind of proof of concept, basically, to make sure that we're controlling the registers and, well, the SEH, like we'd expect it to. So here's the fuzzers. I went through the exploit, showed Metasploit itself, got the successful shell. So I think that's about it. Thanks.